Greetings to the learners. In this video, I'll talk about, is growth always good for the software products, or are there any situations in which the growing demand for a software product can act negatively on its life cycle? We will end the discussion with some architectural guidelines. I'm Dhawan, an engineer and architect for the last 2 decades. When learning is fun, sharing is joy. Speak to the point. During runtime, your product uses many system resources like the memory, the processing power, the disk storage, or network bandwidth. When the demand for your product uses increases, you will increase one or more of these resources to handle the additional demand. When the demand increases horizontally and more number of users start using your product, you will increase network bandwidth so that more number of users can connect to your product. When the demand increases vertically and more amount of data or transactions arrive at your product, you will increase the disk storage or processing power. This increases the capacity of the product. That does not mean that your product is automatically capable of handling the additional demand. The, the capacity turns into capability only when the underlying system architecture of your product supports that. The architecture should support leveraging the additional resources available for the product throughout end-to-end workflows. I'll take you through an example. One of our clients who is into automobile sector has created a product known as Catalog Viewer. This product provides an interface to query the master data of the spare parts. This is a web-enabled product which contains a web server and a database server. The web server connects to the database server and retrieves the information and presents it to the user. This was initially designed for a small set of users who are into sales planning. The web server uses a set of connection objects for establishing parallel connections with the database server. For that, it uses a connection pool which comprises of a set of ODBC connection objects. So this has provided the response time. This has provided the response very fast to the limited number of users who are using this product for the sales planning. As the product becomes successful, more number of departments within the organization wanted to use this product, the Catalog Viewer. So the departments of sales executives and the team of the billing team also wanted to use this Catalog Viewer. So when they started connecting to the web server, the response time of this web server has dropped down. This is because the requests are arriving late and the responses are transmitting late back to the callers. So due to network congestion. So knowing that the product team has increased the network bandwidth that is allocated for this cluster. Even after that, there is no improvement in the response time what they are getting it from the product, the Catalog Viewer. This is mainly because web server uses a connection pool to connect to the database server. To establish parallel connections, one connection for each active user. One connection for each active user. So as the web server makes use of the connection pool, which is a limited set of connection objects, if the number of active users, if the number of active user sessions is more than the number of connection objects available in the pool, then the balance user sessions have to wait in queue. So that makes the web server to send the response very late, which means to say that the additional network bandwidth that has been allocated to the cluster could not be converted into the increased capability of the product to handle the additional demand. That's because there is a bottleneck in this architecture. So as the overall response time of this web server has gone down, the user experience went down. Even the sales planning team, who were happier earlier, got dissatisfied about the current performance of this web server. Then the management asked the architect why the performance of the product cannot be improved. The answer was that this product was not designed for such a large number of users. Then the management has decided to replace the product with another one which can scale up to the increased needs of the business. In products lifecycle terminology, this phenomenon can be seen as a product dying of its own success. So when the catalog viewer was initially launched, it was performing very well with the first set of users, the sales planning team. But as the demand has grown, it was unable to meet the additional demand. The capability of the product could not be increased to meet the additional demand because there is a bottleneck in its architecture. To avoid that, the architects need to take care that their architecture doesn't contain any bottlenecks that can stop the product from handling the additional demands. In this case, using a distributed data storage could have avoided this type of problem, like using a separate data store for each of the user groups and using asynchronous calls to connect to these individual data stores could avoid the connection pool as a bottleneck. The product's response to the growing demand is binary. If the architecture supports the capability scale up, then the product multiplies its success. If the architecture doesn't support capability scale up, then the product will die, but it will not be at the same state. The approach what the architects would need to take to avoid these scenarios is they need to be optimistic about the growth of the product. We may not be able to create a design that will cater to a large number of users on day one itself. But the minimum thing what we need to take care in the architecture is that it should not contain any bottlenecks that can stop the product from growing. So what do we take from the discussion? Is growth always good for a software product? It depends on the architecture. If the system architecture supports the capability scale up without any bottlenecks, and if it leverages the capacity augmentation in its end-to-end workflows, then the growth is good for the software product. If it doesn't, the growth will be a risk to the product's life cycle. Thank you.